welcome to AURO University, Dr. Sandeep and Dr. Joshi. First of all, Sandeep, let me introduce to my colleague from the School of Science. He is Dr. Nikit Desmukh, and he is from physics background.
Okay. Hello.
So, hello everyone, and a very good evening to all of you. I hope you all are safe and healthy. I, Dr. Subhendu Chakravarti from the School of Science, AURO University, would like to welcome you all on today's webinar. This is our first webinar from the School of Science, and we do hope to do a lot more of this, as this medium will certainly allow us to reach out to a lot more people across time and space. In our AURO University School of Science, we have started undergraduate honors course for 3 years in chemistry, physics, mathematics, geology, botany and microbiology. Our BSc honors course are so designed that it is not limited to academic learning, but we take care of the holistic development of the students and emphasize on practical skill and industrial exposure. We are developing a very good collaboration with many national and international lab and institute where students can go for an internship. Now I am pleased to introduce today's speaker, and on behalf of AURO University, I extend my warm welcome to Dr. Sandeep Gholap, who is a research scientist at KAUST University, Saudi Arabia. Dr. Sandeep has completed his PhD from Riken Saitama University, Japan. Apart from postdoctoral experience, he has industrial experience in Lupin, Glenmark in India and Riken in Japan. Today he is going to discuss on using carbon dioxide as an application in organic chemistry. Now I would request Dr. Sandeep to make the opening remarks and take over the discussion.
Okay, thank you, Dr. Subhendu, for your kind introductions. Good evening to all. And I first would like to thank you, all the peoples who behind to start this first webinar for this university. And today I'm going to share my research, and most of the part I will talk about the opportunity in future for the students who are now attending this webinar. So I'm going to share my screen so you will get an idea what I'm going to talk about. So first off, I would like to share my okay, so do you see my slides?
Yeah, yes.
Okay, so this is all first page in details. So I will first talk about the opportunities in India. Basically, after the 12th standard, most of the students are so confused to which faculty we have to choose and which is the best career. Apart from commerce, arts and science, these are three faculties which are the major, and if you will go further in details into the different kind of faculty, you will get the more and more information regarding. So today I'm just only talk about the science. The very special and well developed faculty for science, that is bright career for the students who want to join this type of these faculties, because of there are a lot of science related faculties and subjects are available, and for that purpose many people will go this kind of this substitute subjects for their career. So if you will go further and if you will take, there is lot of opportunities in if you will go for the research, you will have a lot of opportunities in research. I'm going to tell you in details the research. Very technical programs specifically for the engineering faculty. These are the important future for the students who want to pursue their career in technicals and medical field, as well as biomedical, paramedical fields. These two medical fields is related to our health. Also the medicals, which is related also chemicals, pharmaceuticals. Also most of the opportunities for the educations, like you will also go to any kind of universities, many institutions and many colleges for as a teaching or doing their research. So these are the some types of this overview for the science faculty. And after 12th standard, if we'll choose bachelor in science, there must be how to do PhD and go higher level for the master after PhD and go for the higher research. So the opportunities after PhD and master, you will have opportunities in research. there are specifically more CSR laboratories now developing and well-developed laboratories throughout India. Even you will go for the IITs, Indian Institute of Technology, and various pharmaceuticals also in India, also chemical industries and IT. These are major resources and major facilities which we can build our careers and go for this institute to get experience, get internships, and take your knowledge through it. So I'm going to share one video that is the one. This is a part of one NCL is National Chemical Laboratory. So you will get an idea how there the environment will be there. So this is, I'm going to celebrate this one just for its 2 minutes so you can get an idea.
Sandeep, we cannot see the video. Sandeep, we cannot see the video.
You couldn't see the video?
No. Share the screen, full screen.
Okay. This is related to the National Chemical Laboratory, which is built in the Pune, and I just want to show all of you for the these things that what is the facilities available in such a type of institution. And this is one example. So throughout, if you will search in the Google, you will get the more CSR laboratories and how the research will and how the people will enjoy their research in this institute. So as the video is not working, so might be we will go ahead. So these are, and also there are some opportunities for the pharmaceuticals and chemical industries. So most of these 20 generic companies right now is in India. So the most of the students has an opportunity to join this type of companies for internship as well as their career. So basically this Glenmark and Lupin, I was worked there for almost 10 years. For Lupin, I worked almost 3 years, and rest of the years I work in Glenmark. The environment is very good for this institute, and also you will get more and more focus on the research as well as various chemical background. So this is one opportunity for the students who are now wanted to choose their science as a career. They can go and pursue the career in such type of this university. So now we'll go outside. What is the opportunity in outside India? So basically, I did my PhD in Recon and affiliated to the Saitama University. Recon is the very famous university research institute like the CSR labs. There, you can do a high quality research in all the field like physics, chemistry, biotechnology, forensic and astrology. So this is the one kind of research institute. I want to show this video, but this video is not working. I don't know what. Let I try once time. I'm not sure if it is working. Can you share my video? No?
Sir,
Okay.
first of all,
Fine,
you
fine,
start
fine.
it. Sir, first of all, you start your video and then
Yeah.
go to share screen. Over there, you are able to see your videos.
Start the video and share the screen. Then you can share.
Yeah, I think that's a better idea.
Yes, now we can see it. Yeah. Now we can see it.
Yeah, okay. Earlier, there's same problem of that. So now this is explaining about the, most of you people know the 113, which is neonium elements, which is discovered by this Recon Institute. So far, this is the one thing that this institute has a worthwhile research throughout this, using various types of these facilities. So I'm going to stop this and we will continue for this one. So you will get an idea about the research facilities and the research was is happening over in this institute. Okay, let's come to our so later on I started to join. Do you hear me?
Yeah, very well audible.
Huh?
I can see your screen.
Yeah, very well audible. Please proceed.
Okay. So as I told, this is the Recon Institute, and next is I spend some more time in the advanced research, industrial research technology as a senior researcher. There are also the many facilities that's available over there. So just earlier that I told you that this type of the well developed institute where we can also pursue our career through outside India. Also currently I am working in Saudi Arabia, where this is King Abdullah University of Science and Technology. And this institute is famous for the research advance with well developed around scientists around the world. They can come over here and they do the research as per their choice. So this is one point.
Excuse me, Sandeep. We cannot see your PowerPoint.
Why?
We cannot see your PowerPoint. Please share screen again. Yes. Now we can see.
Okay, now it's fine.
Continue.
Okay. So currently I am working in Saudi Arabia. The name of this institute is King Abdullah University of Science and Technology. This university is well nominated for the higher research throughout the world. And if you Google search, you will get an idea. This is a very prestigious institute where also the chance for all students, they also come over here for the internship, for the collaborations and doing their research honestly. And we'll just come to our main topic, that is the recent global challenges. So I'm going to focus on only 5 challenges. There are more global challenges, but these all challenges are including in this case. First is the extinction of wild animals, peak oil consumptions, global shortage of food and energy, and economic collapses. There is another one very important challenge is global warming. Why this global warming is happen? Okay, global warming is happened due to a climate change, and most of us we know that the Earth average land temperature is nearly 1 degree Celsius, and this is need to be seriously considered, because if the temperature of Earth is increased by 1 degree Celsius, means what are the problems? Why this is the reason. So there is a water shortage, crop failure, changes of cloud formations, sea level rise, and many other climate change. And like using carbon monoxides, carbon dioxides, chlorofluorocarbons, and other greenhouse effects. These are all the concerns for the increasing the temperature of this Earth by 1 degree Celsius. And that is why I'm going to try to convince you for how this carbon dioxide is useful for chemical synthesis. Most of the challenges for using environmental problems, as all of we know, because of there are many vehicles on the road and there creates a lot of pollutions. That lot of pollutions due to these environmental problems. So this is 5 types of the problems right now we are facing, like air pollutions, acid rains, water pollutions, greenhouse effect, research center, green page. So I'm going to talk about a little bit about the greenhouse effects. So most of the gases, as I mentioned over here, like carbon monoxide, carbon dioxide, they are very much responsible to get the greenhouse effect, and that's why the temperature of the Earth is going to increase. Simply, the carbon dioxide is just which is how like this structure CO2. This is simple unit, and it is very, very stable, and it is very difficult to use as a organic compound for the synthesis of various type of these chemicals. So far, we'll go before this ones. The global greenhouse emissions biogas. If you consider carbon dioxide, which is come from the fossil fuel, which is really 57%, and which is need to be serious concerns about this one. How we can solve these problems? If you go further, carbon dioxide and carbon other source, which is biomass for deforestation, and also this other type of these gases. But if you consider these two carbon dioxides, which is main concerns around the world to face the problem for these global warming issues. So far, if you will consider the carbon dioxide cycles, it's very simple carbon dioxide cycle, as most of we people, students studied about this, how the carbon dioxide cycle works. Means when it is through the photosynthesis by using sunlight, plants will use these carbon dioxides, and after the respirations and animal respirations, once we utilize, and we will just relieve carbon dioxide, and again it's come to the environment, and that's why the carbon dioxide is increasing nowadays. Simplify, if we will consider, this is the very simple carbon dioxide cycles. Like if we will burn the fossil fuels, we will burn fossil fuels, we will get the energy, but we can release again carbon dioxide. And from the fossil fuels, if we will form any organic compounds, we'll again combust, and we'll get the energy, and then we will release carbon dioxide. And this carbon dioxide is generally used only plants for their photosynthesis, which will give the mass as a food. So biomass we can get a release. But how we can use this carbon dioxide? Which is this carbon dioxide, you know very well, this is naturally abundant, and it is non-toxic and also inexpensive. And one way, if we will use this one, we will minimize the carbon dioxides on the atmosphere. And this is only a short use of carbon dioxides to use carbon dioxide. And if you do the organic synthesis, what will happen? Can we use the carbon dioxide as a gas to synthesize the organic compounds that is usually used in very pharmaceutical and the chemical industries? And if you go, this is the application for the carbon dioxide. Most of the carbon dioxide, which is used as a solvent, as a anti-solvent and co-solvent. Also, it is also used for the various type of these natural matrices, which is further extractions, and we'll get a bioactive compounds. This is a total use of this carbon dioxide. If you will play with these two, if you will go direct use, you can use at the food, carbonated drinks, and enhanced oil recovery. If you will go for chemical and biological transformations, two ways we can. First, we get the manufacture of synthetic fuels, and further we'll convert it into chemicals. And these chemicals further will have most of the polymers, which is used this carbon dioxide. And for polymers, we'll know that we will get the plastics. Further, this manufactured synthetic fuels, we give the designer fuels, means we have to build up a fuel for using such type of carbon dioxide. And for the manufacturing the chemicals, which is I just told, we will use organic synthesis as well as minerals. So this is a proposed application for these carbon dioxides. So carbon dioxide as a C1 source, because carbon dioxide contains CO2, one carbon and two oxygen in it. After using catalyst and photosynthesis, we get the fine chemicals, which is used as a fuels. What is the fuels? For example, from CO2, we'll form methanol. Methanol is used as a fuel. Formic acid, we can use as a fuel. Even we can transfer it into various types of these chemicals. Also, we can use it as various formation of the various types of these polymers. So this type of this use of this carbon dioxide to synthesize various chemicals and fuels is an increasing interest into this field. So far, if you will see, this is one detailed things that how the carbon dioxide will use in organic synthesis. These all are developed methods for use this carbon dioxide. You can see for here most of these organic compounds which is use carbon dioxide to synthesize. So there are many things that many chemicals to use for such type of this formation of these compounds. But if we can use carbon dioxide, we can use this carbon dioxide to transfer into useful products. This is one type of the solutions. I'm not talking about the global solution that we can just use all type of carbon dioxides and we get into, but the research is going on. And in future, right now the current research is, now we are using carbon dioxide as a fuel. Most of the carbon dioxides we can use it, and most of people may know that currently people are using formic acids, which is a very good fuel for the fuel cars. Right now, if you search Google search, the formic acid a best option for using as a fuels. Right now, the current situation that we cannot use formic acid, still research is going on there to use high turnover numbers to use formic acid, because formic acid which is converted into carbon dioxides and hydrogens, and most of people we know that hydrogen is used as a fuel, and coming 20-30 years we will just use hydrogen as a fuels to avoid this type of these pollutions. So I mentioned over here shortly to how we can synthesize this type of these compounds using these carbon dioxides. So previously, we also have, my major work is we are using some type of this catalyst and carbon dioxide to utilize this carbon dioxide into a major type of these organic compounds. I'm not going to go in details to because of the short of time. Otherwise, I may go in details how we can use these carbon dioxides and how we can synthesize such type of these compounds. Then my last message is for everyone, that is the only solutions right now we have to reduce, we have to reuse, and we have to recycle. These all three right now we might be to provide green solutions for the our society. So thank you for your attention. I'm not giving all the details because of the times, and if I future an opportunity, I will go for 1 hour to go in details to how the carbon dioxide will use as a source, C1 source for the various type of this organic synthesis. And thank you for your kind attentions. And if you have any questions, right now I'm ready. If time is there, and if time is not there, this is my email ID. If you have any questions regarding the future opportunity inside the country, India, or outside the country, then I may help, because I have many contacts throughout the world, so many friends over there, and they can also give an opportunity and suggestions for the students, because I got the information from Dr. Subhendu that most of the people joining this webinar are the students, and they need some information how we can pursue the career in science. So this is my email ID. If you have right now, if time, you might ask some questions, or if the time is running, then you might write the email to me, and I will try my best to give the answer for your questions. Yeah, thank you very much for your attention. Yeah.
Thank you, Dr. Sandeep. Since we are running out of time, queries can be sent to us or to Sandeep Gholap directly via email. We'll definitely forward it to Sandeep and get back to you with his recommendation and response. And thank you once again, Dr. Sandeep, for sharing your knowledge and experience with us and enlightening us on pursuing a career in science. I hope our students and audience will be benefited from this session. And I would also like to take this opportunity to thank few people who are behind organizing this webinar, and hence we can get the benefits of learning sitting at our home. I would like to start by thanking our Honorable Founder Sri Rama Sir, VC Sir, Dean Sir, Register Sir, IT members, marketing members, and admission office members, and all my colleagues from AURO University for making this webinar a great success and leading us an opportunity to share and learn. Now I would request Nikki Sir to take over this session.
Okay, thank you. So I would also like to thank Dr. Sandeep for his precious time. Should I start the next speaker's procedure? Is he there? Is he there? Dr. Joshi, you are there? Hello. Hello. Dr. Niro, are you there? Okay, let me find out. Hello, Dr. Nirav, are you there?
See you.
Yeah. Are you able to see?
So?
Yeah, are you able? Hello. Hello, Dr. Nirav, are you there?
Niket.
Okay, are you there, no, Nirav?
Yes.
Yes. Okay. So now we are going to start your session as the previous session has ended. So, as let me first particularly say about something means actually Dr. Subhendu sir has very well briefly mentioned about the AURO University. So from the AURO University itself, from the School of Sciences itself, we are happy to have you, and we would like to hear something from you related to your topic called this nanotechnology. Is very give some introduction about Dr. Nirav Joshi, who has been particularly doing the research in this nanostructures and nanogas sensors and all those sort of subjects. So first of all, Dr. Nirav Joshi is a doctorate from the good old Gujarat Maharaja Sajirav University of Baroda, and he has been pursuing his present research from the Institute of Physics from the Sao Paulo, which is a part of the University of Sao Paulo in Brazil. So he has particularly also did his various postdocs from Bhabha Atomic Research Center as well as from South Korea. Recently, he has returned from the California, Berkeley, where he has pursued his research in developing the selective and sensitive microsensors. And now he is pursuing his research in the oxide nanostructures. He has been also particularly reviewing many of the peer-reviewed journals. Along with that, he has published some 5 books, 20 peer-reviewed publications to his merit, and as well as he is some editor of the Elsevier journals. So the list is kind of endless, and as well as he was awarded twice by the Electrical Research and Development Association (AURO) in India for his best R&D patent award. So without further having some like consuming the time, as we are running short, having these 2 seminars organized at the same moment, so I will not consume much of the time, and I would like to request Dr. Nirav Joshi along with my two sciences staff members, introduction of Dr. Neha Bhatnagar as well as Dr. Subhendu Chakravarti. And we welcome you from the AURO family side, and have to have your particular this topic of nanoscience and nanotechnology introduction, as particularly the students, or say the masses, are mainly the students which need to have the concern related to your topic. Okay, so I request you to start the presentation. Yeah.
Thank you for the introduction, Dr. Deshmukh. I think I'm facing a problem to share the screen.
Okay, first you have to open your PowerPoint, and then I think you have to share the screen. Correct me if I'm wrong, somebody.
Yeah.
So you'll have to start the PowerPoint first.
Yeah.
Then click on share screen. You will be able to see your PowerPoint. Click there and share.
Okay.
Okay, I think you can start the slideshow and then you have to share the screen, something like this.
Okay.
Okay. Okay, we are able to see.
Okay. Okay, so
yeah, it's visible.
Visible. Okay. So thank you for the introduction, Dr. Deshmukh, and thank you for joining and giving me this opportunity to give a talk on introduction to nanoscience and nanotechnology. So I'm going to spend some few minutes on basics of nanoscience and nanotechnology. So my name is Nirav Joshi, and I'm a researcher at University of Sao Paulo, Brazil. So my core research area is functional nanomaterials-based gas sensor. And in the plan of my talk, mainly I'm going to talk about some basics of nanoscience, nanotechnology, and nanomaterials. We'll see some properties of nanomaterial, application of nanotechnology, and some suggested references for the students. So the question is, what is nano? The talk of the town, like COVID-19, how the relation with nano and COVID-19. So let me give you the one example, that the World Nano Foundation has used the rapid COVID-19 kit by introducing a gold nanoparticle into the testing strip. And the features of this kit are, it can take only 3 minutes to give a positive result and 15 minutes to generate the results if your result is negative. And also it is easy to use and no additional equipment required. Let me give you one more example. You all have seen the latest Avengers movie, and let me show you my favorite scene.
Where'd that come from?
It's nanotech. So nanotech is everywhere, and the good thing is people are using in their everyday life. And the question is, what is nanometer in this sense? So a nanometer is a 1/1000th of meter. The term nano comes from the Greek word meaning dwarf, but nano is definitely smaller than a dwarf. and in scientific community, it refers to 1 nanometer. So nanoscale is actually a nanometer scale, and the range of this scale is from 100 nanometer to 1 nanometer. So nanometer is a scale used to measure objects in the nano world. So how small are nanostructures? Let's take a single hair. The width of the single hair is around 0.1 mm, which is equal to 100 micrometers, and that is 100,000 nanometers. But do you know that a human fingernail grows 1 nanometer every second, and a man's beard grows 5 nanometers every second? Let us have a comparison chart between this micro, macro, and nano. So at a macro scale, the height of the person is around 180 centimeter, which is equal to 2 billion nanometer. But in the micro scale, the human hair diameter is around 80,000 nanometer, and the smallest the eye can see is 10,000 nanometer. But compared to macro and micro, at the nanoscale, the diameter of the DNA is around 2 nanometer, and the cellulose nanofibrils, which is in the plant leaf, the diameter is in the range of 3.5 to 100 nanometer. Similarly, the size of the tennis ball is around 10⁸ nanometers, but the nano devices like nanopores, nanotubes, nanoshells, they all are in the range of 10 to 100 nanometers. In this slide, you can see that a silver wire resting on a human hair. Look at the strand of your own hair and imagine how small that is. Even your naked eye cannot see the silver nano wire. So the question is, what is nanoscience? Is it biology? Is it physics? Or is it chemistry? No, it's all of them. Disciplinary science. Let's talk about some history of nanotechnology. So, we cannot forget the 3 champions of the nanotechnology. The first one is Richard Feynman, who gave the term nanotechnology in 1959 in his article, and he mentioned that there is plenty of room left at the bottom. The term nanoscience was first defined by Japan scientist Norio Taniguchi in 1974, and also the contribution of Eric Drexler on seminal studies of the molecular nanotechnology in 70s and 80s. The question is, we have micro, we have macro. Why we need nano? What is the use of nano? Because it is faster, it is lighter, it is cheaper, and it is more energy efficient, and also can get into small spaces. For example, the anti-drug carriers cannot enter into the mammalian cell because of the size. But if we have a nano-sized material, it can enter and easily locate the place of the tumor. Let me give you one more example. Take a 1 Disprin tablet, and by just putting into the glass of water, it will take around 45 to 50 seconds to dissolve. But do the same experiment and just crush the Disprin tablet, it will take around 10 to 15 seconds. So when the size goes down, it can work efficiently because of the high catalytic activity. Let's take one more example with the properties of nanomaterial. What do you think? Which of this is gold? This one or this one? They both are gold. One is a bulk material and one is a nanomaterial. And at the nanoscale, strange things happen to materials. Their properties can change. Different sizes of particles react to light differently. The color of gold can range from purple to red depending on the size of the atom clusters. In also the zinc particles in sunscreen, the large zinc oxide particles appear white, but the nanoscale zinc oxide particles appear clear. The zinc oxide in sunscreen is very obvious white in its microparticle form, but almost undetectable in its nanoparticle form. The reason is the zinc oxide particles can scatter and absorb the sun's ultraviolet radiation and prevent sunburn. Let's discuss about the size effect on the properties. So first is the physical properties. So when the size goes down at the nano level, the melting point goes down, and it is known as melting point depression. Similarly, in the chemical properties, when the size goes down, it reacts efficiently because of the high catalytic activity. For the mechanical and magnetic properties, when the size goes down, it works very efficiently, and also we'll see what is the effect of magnetic properties when the size goes down. And also electrical properties. So non-conductor can behave like a conductive material at the nanoscale. And in the optical properties, when the different size and shape can affect the optical properties. Here you can see the gold nanoparticle with 100 nanometer and gold nanoparticle with 50 nanometer. With a different size, it has a different color radiations. And, this picture is for the magnetic nanoparticles. So the question is how we can prepare this kind of nanostructures or nanomaterials. So there are approaches to prepare these nanostructures. One is the top-down approach. So like building something by starting with the larger component and carving away the material. It's similar to making a sculpture from the rock. Just imagine that this rock is your bulk material and statue is your nanomaterial. So by carving this rock and making this statue is like from top to down approach. And to prepare this kind of nanostructures by using top-down approach, there are some methods like lithography, deposition, etching, and machining. Second is bottom-up approach, like building something by assembling smaller component, like building a car engine. So by using bricks and making a building, it's a bottom to top approach. And there are some methods like chemical processes, 3D printing, and chemical vapor deposition. They all are used for bottom to up approach. So let's take a difference between nanoscience and nanotechnology. Nanoscience is a study of nanomaterials and their properties related phenomena. Let's take an example of quantum dots. So quantum dots are a semiconductor nanocrystals, and it has a different fluorescence property with respect to size. So when we are talking about the physical and chemical properties of a quantum dots, that is called nanoscience. But by using these quantum dots, making a slim LED TV, that is a nanotechnology. So nanoparticles are using in different areas like renewable energy, biomedical, healthcare, industrial, electronics. And let's see some applications in detail. For example, the first iPod came in 2001 with a data storage capacity of 10 GB, and by year it increased. And now in 2020 we are using the iPod with 256 GB data storage capacity, but with some advanced feature like long battery life, touch screen, smaller in size. Even for the hard drive, so magnetic data storage, nowadays people are using solid state drive. So the reason is the magnets are going down at nanoscale, and that's the reason they are using a nanotechnology. Nanotechnology, some nanomaterials are used in cosmetics like anti-wrinkle creams and sunscreen. Also, nanofiber nanoparticles or nanomaterials, they are used in sport equipments. Also, scientists are hoping to make a space elevators to see the orbital movements. Nanotechnology is helping to build a faster processing supercomputers, mobiles, and smartphones. And maybe you have seen that IBM has produced a prototype chip with transistors that are just 7 nanometers wide. So you can imagine that how this technology is helping to build this technological world. It is also used in the energy storage devices and treatment of water. And do you know that some solar panels, by using the nanotechnology, they boost the efficiency from 15% to 46%, and it will climb to 50% shortly. Nanotechnology is frequently used in paint industries too, to improve the functionalities such as water dirt repellent, UV protection, antimicrobial resistance, scratch resistance, and also it is used in coating industries. Let me give you one example. The red light district of Hamburg city in Germany, they coated the surface of the wall with the nano coating to prevent the urination. So the thing is, it able to pee back when you do this. So it's interesting, but that's all uses of nanotechnology. So in summary, what we learned that what is the size of nanomaterials, why small is good compared to bulk material, why it is beneficial, how the material properties change with the size of the material, how we can prepare these nanomaterials by top-down and bottom-up approach, and also some overview of application of nanotechnology. There are some reference books like Encyclopedia of Nanoscience and Nanotechnology by Hari Singh Nalwa, and also Nanomaterials, Nanotechnologies and Design, Handbook of Nanophase and Nanostructure Materials. There are plenty other books, and you can refer to understand this technology. So at the end, I have a message for the students that nanotechnology is changing practically every part of our life. It is a field for people who want to solve technological challenges facing societies across the world. There are well-paying, interesting jobs in this area, like as a technician, engineer, scientist, manufacturing, sales, and others. So thank you for your kind patience, and I hope you enjoyed the presentation. So stay safe and take care in this pandemic situation.
Okay, so it's very happy. I'm particularly happy to know that we are surrounded by not only right now with the corona things, but also with this nano kind of particles and nanotechnologies, and we are using it in our day-to-day life. And I'm happy to have this talk related to sticking to the basics of the subject, for which I hope the students might have enjoyed that particular session. Both the sessions, in the sense they were meant to enhance their knowledge related to the science streams which are developing, in particularly the new zona. So if there is some question or answer sessions to be done, I think we have time. So if there are some short questions, 1 or 2 or 3, I think we can conduct that one. Is anybody like to know or like to inquire something about this field of nanoscience and nanotechnology? Can please proceed to have the question. Okay, I hope there is nobody having some question, but okay, okay, somebody has raised her hand. I don't know how to connect him to ask the question. Can anybody help me? Hello? Hello? Okay, there is a question like, is there any legal challenge with regard to nanoscience? Dr. Neerav
I don't
Joshi.
think so. Is there any legal challenge with regard to nanoscience? The thing is, we need to optimize a lot this nanoparticles and nanomaterials to make a device. As I mentioned that IBM has produced a 7 nanometer wide transistor. So it's not an easy task. I believe you need very advanced technology to build this kind of devices, clean room facilities and other things. But apart from that, I don't think so. Is there any challenge in this nanoscience?
Okay, so this question was from Frenny. I believe the person or the student is satisfied with his answer. Okay, so I also like to not give ask a question, rather a comment. I have to ask Dr. Joshi that can you just throw some light at how this type of studies could be procured? Like, what are the basic things we need to study at after 12th to go in the field of this nanoscience and nanotechnology, or like in India, which are the institutes which are premier to have this nano studies pursuing in their strength?
Okay, about the nanoscience, in 2017, I think Department of Science and Technology, they started one program on nanoscience. So it is, I think, Professor Sienna Rao is the main person who is taking care of this scheme, and I believe it is a growing technology. And first of all, after the 12th, obviously you need to understand the basics of all the physics, chemistry and mathematics in your engineering or science stream, and then later on you can just get some more knowledge about the nanoscience and nanotechnology.
Okay, so Dr. Joshi, I believe there is also one question from Basant Kadan, that what would be the application of nanotechnology in the study of ultrafine particles in the air?
What will be the application of
nanotechnology in the study of ultrafine particles in air?
You mean like if the ultrafine particles in the air, how you can prevent or how you can take care of this ultrafine particles?
Or basic application, like what is that particularly from the nanotechnology point of view?
Yeah, people even nowadays people are using nanotechnology to prepare a mask to prevent this kind of ultrafine particles, and even they are making sensors on this mask, so that if some kind of microparticles or nanoparticle, ultrafine particles in contact with that mask, it can give you the signal that your mask is contaminated with this kind of ultrafine particles. I hope it's fine.
So are there any questions related to this fascinating world of nanoscience multidisciplinary subject. Yeah, is what I'm saying.
Okay.
Okay, so I believe now the question and answer session is kind of well, okay. You can always get in touch with Dr. Nirav Joshi. I believe
Sure.
yeah. If we get the opportunity to invite personally Dr. Nirav Joshi, we will also be happy to have him and deliver such topics, because the nanotech science and nanotechnology which he delivered currently was from the basic from the student's point of view. We would also like to have his research-oriented study to be extracted, or to be say to see. We will be happy to see that one, that how he has pursued his research and on the that gas sensors and all that topics he has been specialized. So in future, we hope that we will definitely have some specialized core lectures or say sessions from your side, and we'll be happy to host you again. So, okay, I finally like to end the session by thanking my AURO family.
Thank you very much.
Putting so much effort. Yeah. Also like to authorities, as well as the people who are like quite of creative persons and IT related persons who have managed to run the seminar in a very smooth, or say a webinar in a very smooth way. So I take the privilege to thank you all, and also to the speaker, Dr. Nirav Joshi, who wake up early in the morning on just my one call to deliver a webinar, because I know it was a very short span. I gave him like 5 to 6 days and requested him to appear for this our new upcoming School of Sciences in our university. So I thank you, and I'd like to end the session. If there are some comments or suggestions, please you can have it. Otherwise, we can end the session.